So in 7 through 10, we looked at how to set it up with the A and the B. Now for 15 through 25, we're going to find those numerators for the partial fractions. So let's look at case 1 first. So that's where we have distinct linear factors. So 16, actually from 15 to 40, you're doing 15 through 25, the odds. So I pulled an even for an example. So for 16, we already have our linear factors factored out. So the factoring is done for us. So I know I have distinct linear factors. I have an x and I have an x minus 1. So I know that I'll have one partial fraction for the x and I'll have one partial fraction for the x minus 1. I just don't know what the numerators are going to be. But I do know that when I add them together, I will get this. So what happens if I did add them together? What does that look like? Well, to add them together, I have to get a common denominator. So I'd have to multiply a over x. I'd have to multiply it by an x minus 1. And the b over x minus 1, I would need a factor of x in there. So I'd have to multiply both of those by x. So my common denominator becomes the x times x minus 1 over minus 1. And my a and b, I end up getting a times x minus 1 plus b x all over x times x minus 1. And remember, that equaled our original thing, the 1 over x times x minus 1. So that means our numerators must be equal. So that means that the a, actually I'm going to write it over here, a x minus 1 plus b x equals 1. So now let's try to solve for a and b. So I'm going to distribute my a to get rid of my parentheses, and I get ax minus a plus b equals 1. And then combining like terms, I get, let's see, ax and bx are like terms. So that means I can write a plus b x. And the minus a is a constant. That equals 1. Actually, I'm going to express that in terms of this form. So that's 0x plus 1. And I want that x, I want that x in there because now I can recognize this form and say this part equals the part that's in front of the x, and this part is my constant. So a plus b equals 0, and negative a equals 1. So now I have a system of two equations and two variables. So if a plus b equals 0, I actually have negative a equals 1 is already in one variable, so I can solve for a and find out that a is negative 1. So if a is negative 1, then plugging that back into this equation gives me that b equals 1. So now I take that a and the b, I have an a, I have a b, and I plug that back into my original setup, the setup like we did in part 7 through 10. So I'm going to take those and I'm going to plug those back up here. So I have a over x is now going to be negative 1 over x. And my b over x minus 1 is now going to be, the b is now 1 over x minus 1. So there is my partial fraction decomposition. Okay, let's do another one. So again, I have my denominator has already been factored, and I can see it's distinct linear factors. So for each one of those factors, I'll have a partial fraction. I don't really need the parentheses since the fraction bar works as a grouping symbol. But I don't know what those numerators are going to be to give me the 8x minus 13 after I found a common denominator and added. So what does it look like? So if I were to add these together, I need a factor of x plus, remember I need an x plus 1 over here in order to get that common denominator. And I need an x minus 2 over here in order to get that common denominator. So when I do add these together, I will get a times x plus 1 plus b times x minus 2 all over x minus 2 x plus 1. And then remember that all equaled our original fraction. So I know that numerator is going to be 8x minus 13. So that means this numerator must be 8x over 13. So I can set that equal. So a times x plus 1 plus b times x minus 2 equals 8x minus 13. Now solving for a and b. So I'm going to get rid of my parentheses and I write ax plus a plus bx minus 2b equals 8x minus 13. And then I'm going to combine like terms. So my like terms, I combine my x's, and those are going to be set equal to 8. And that's a plus b x. And then I combine my constants. Oh, whoops. So I have a minus 2b is my constant, so that's going to be equal to the 13. So my a plus b equals 8. Looking at a, whoops, actually no, what I need to do is copy that there. So now you can see how the a plus b corresponds to the 8 and the a minus 2b corresponds to the negative 13. So a plus b equals 8 is my first equation, and my other equation, I guess I should have kept the orange, is a minus 2b equals negative 13. So now I have a system of two equations and two variables, so I can solve those. So I'm going to use it so we can do substitution or elimination. If I add these two equations to subtract them, actually, let's subtract them. So I'm going to take this and do a negative a plus 2b equals positive 13. So I just took that equation times a negative 1. When I add those together, I get 21. The a's drop out and I get 3b. So b equals 7. And I can substitute that back into the other equation to get a minus 2 times b, which is 7, equals negative 13. So a minus 14 equals negative 13. So adding 14 to both sides, I get 1. So a equals 1, b equals 7. Now I can take that information and plug that back into my original, the format that I set up on that first step. So a was 1, so my a is 1, so I have a over x minus 2, and b is 7. And that is my final partial fractions.